Hi, in this video I'm going to explain how to go from Z to P, that is, how to start with a range of Z-scores and find, and it could be worded in terms of probability, what's the probability of a Z-score being less than 1.18, or in terms of proportion, what proportion of all Z-scores are less than 1.18, or what percentage of all Z-scores are less than 1.18. Or it could be worded in terms of area. What's the area under the standard normal curve to the left of the point where Z is 1.18? Turns out the answer is 0.8810 or 88.1%, but I'm going to explain how you would find that. And there's more than one method you can use. In this video, I'm going to explain how to find this using the table for the standard normal distribution. So this is method one, using table E. Where can you find table E? Well, one place you can find it is in the back of your book. If you look in the back of the book, on pages 788 and 789, and that's in the section with the blue edges, you'll find two pages that look like this, and they say Table E. You can also find this table on the important formulas card that should have come with your book. Now, it might not have if you got a book that somebody else had used before and they didn't return the card when they returned the book. But you might have this card with your book, or you might not. But if you don't, I do have it posted on Canvas as a PDF, so you can download it, you can look at it on your computer. If you have a printer, you can print it out. So two of the pages on that card have this table E on them. So you should be able to find this table somewhere. You should be able to look at it in the back of your textbook, or on that card, or on the version of the card that I posted on Canvas. Now let's look at how this is laid out. It's two pages, and on the first page, the numbers down the left side are all negative. So the first page is for the negative Z values. And then the second page of the table has all positive Z values. Now, those numbers, those Z values running down the left side of the table, those give you the first two digits of your Z-score. There's one digit in front of the decimal point, and then there's one digit, a tenths digit, right after the decimal point. And then running across the top of the table, you have columns for 0.00, 0.01, 0.02, 0.03, and so on. And so that refers to the hundredths digit of the Z-score, the second digit after the decimal point. And then throughout the middle of the table, not what's around the outside, but all this stuff in the middle, is a bunch of numbers that look like point something, 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 something. Like there's 0.0018 or 0.5438. So they're all four-digit numbers with a decimal point in the front. So the way this works is the table relates Z-scores with areas. Those numbers that you get around the outside are the Z-scores, and then those four-digit numbers in the middle are the areas. Specifically, they refer to the area under the standard normal curve to the left of any particular Z. So, for example, if you start out with a Z-score like 1.18, the way you would look that up on the table is you would find those first two digits, the 1.1, somewhere in the left column, running down the left side of the page. So there's 1.1. And then you would look across the top of the table to find where the 8 is. So it was 1.18. The hundredths digit is 8. So we're looking in the row for 1.1 and the column for 0.08. And the number that appears in that row and that column is 0.8810. So that tells you that the total area under the standard normal curve to the left of the point where z is 1.18, that area is 0.8810. So the probability or proportion of z's that are less than 1.18 is 0.8810, or that's 88.1%. Now, there are three different kinds of things that you might be asked to find when it comes to going from z's to areas or proportions or percents or probabilities. I might ask you for the area to the left of a particular z value. So that would be p of z less than some number. Or I might ask you for the area to the right of some particular z value. So that would be p of z greater than some number. Or I might ask you for the area between two different z values. So I could write that as p of the first number less than z less than the second number. So let's talk about how you would do each of these, and we're starting with the one that's easiest to do using the table, the way our table is set up, and that's finding the area to the left of a particular z value, or finding the probability of z being less than a particular number. So what's the total area under the standard normal curve to the left of where z equals 0.67? In other words, what's p of z less than 0.67? If you like visual aids, here's what we're looking for. A positive z would be over here to the right of center somewhere. If this is where z is 0 and this is where z is 1, then somewhere in between is where z is 0.67. So if we take that as our dividing line, and then the z's that are less than that would be the ones over here on the left. So we're asking how much of the total area is over here to the left of this line. How much is shaded in here? So we pull up the table. We're looking on the page where the z's are positive, and we look down here and find those first two digits, 0.6. And that tells us which row to look in. And now the hundredths digit, the second digit after the decimal point, is a 7. So we look in this column with the 0.07 at the top. And so the number that shows up here in that row in that column is 0.7486. And so that is the answer. That's the area. That's the probability, 0.7486. Let's try another one. If you think you know how this works, pause the video, see if you can find the correct answer on the table, and then unpause it and see if what I got agrees with what you got. So what's the total area under the standard normal curve to the left of where z equals negative 2.08? In other words, what's p of z less than negative 2.08? A negative z would be over here on the left somewhere, and then we're talking about what's to the left of that. Doesn't look very big. The answer is probably going to be a fairly small percentage. But when we turn to the table, look on the page where the z's are negative, find the negative 2.0 and look in that row, and then look in the column for the 8 in the hundredths place, and the number that shows up there is 0.0188. So that is the answer. The area is 0.0188. So that would be 1.88%, a little less than 2% of the total area. Now, what about finding the area to the right of any particular z value, or the probability that z is greater than some number? The table would give you the area over here to the left. So if what we want is what's over here on the right, we have to take what the table gives us and subtract that from 1. We got to take 1 minus that 4-digit number that we find on table E. So what's the total area under the standard normal curve to the right of where z is negative 1.90? In other words, what's P of z greater than negative 1.90? Pull up the table, look on the page where the z's are negative, look down to find negative 1.9, so that's the row we're looking at, and then the hundredths digit is just a 0, so that's that very first column, and the number we find on the table is 0.0287. Now, if we wanted the area to the left of this z, that would be the answer. But instead, we want the area to the right of that z, so we take this number and subtract it from 1. Our answer would be 1 minus 0.0287, which is 0.9713. Let's try another one. If you want to try this yourself, pause the video and then come back when you got your answer and see what I get. What's the total area under the standard normal curve to the right of where z is 1.42? Or P of z greater than 1.42. Go to the table, find 1.4, and then 2. The number that shows up there is 0.9222. And then we have to subtract that from 1. So our final answer, 1 minus 0.9222, is 0.0778. And now the third kind of thing I could ask, to find the area between two different z values. We have to look both of them up on the table. The table can tell us the total area to the left of one of them, and then we can subtract off the area that's to the left of the other one, and then we get what's in between. So what's the area under the standard normal curve between where z is negative 0.88 and where z is positive 1.10? In other words, what's P of negative 0.88 less than z less than 1.10? We're going to have to look both of these up. I'll take the bigger one first, because in the subtraction, the bigger one always comes first. So if I look up 1.10, the number I find on the table is 0.8643. Now I've also got to look up this other z. So I turn to the page where the z's are negative, and I find 0.1894. And now for my final answer, I've got to subtract those. So 0.8643 minus 0.1894 gives me my final answer of 0.6749. By the way, if you got this in the wrong order, then when you subtracted, you would have gotten negative 0.6749, which doesn't really make sense. Area can never be negative. Probability can never be negative. But if that happens, you can fix the mistake just by making it positive. Next example, what's the area under the standard normal curve between where z is 0.39 and where z is 2.75? Hopefully by now you know how to look both of these up on the table. So you take what you find and subtract. You look up 2.75, you get 0.9970. You look up 0.39, you get 0.6517. And then you subtract and you get 0.3453 for your answer. What's the area under the standard normal curve between where z is negative 2.9 and where z is negative 1.9? That is P of negative 2.9 less than z less than negative 1.9. And if it bothers you that there's only one digit after the decimal point, we could write those as negative 2.90 and negative 1.90. But we look them up on the table, take the numbers the table gives us, subtract, and we get our final answer.